parameter variables. If a script is invoked with parameters, some additional variables are created. If no parameters are passed, then the environment variable $hash is still exists, but it has the value 0. The parameter variables are listed in the following table: $1, $2, $3, and so on, which are the parameters given to the script at command line. And $* is a list of all the parameters in a single variable separated by the first character in the environment variable ifs. If the ifs is modified, then the way the $* separate the command line into parameters will be modified. But in $@, it is a variation of $* and it doesn't use the ifs environment variable, so the parameters are not run together even if ifs is empty. And it is very easy to differentiate in between $@ and $* by trying them out with the following example. That is, I am initializing ifs with some empty string and I am setting the parameters. When I echo with the help of $@, which was enclosed in double quotes, it will expand the positional parameters as separate fields regardless of the ifs value. And in general, if you want to access to the parameters, $@ is the suitable choice. It shows the output like this. And when I echo $*, it shows the output like the following by considering the ifs variable. And when I unset the ifs variable and when I echo $*, it shows the output which was similar to the output shown after executing echo space $@. Now we will look into the example of parameter variable, where I am initializing the variable salutation with hello, and I am echoing the variable salutation, and also I am echoing the parameters like $0, $1, $2, $* and so on. Now I will show you the same on the terminal. This is the code. When I execute it, it shows the second parameter was empty, first parameter was empty, and the parameter list is also empty because I didn't pass any parameter in this line. And $0 is a.sh, which is the program currently running. Now it is asking the user to give the input. When I give input, it shows the output and it executes the last statement, that is, the script is now complete. Now when I pass the parameter for the program, then it shows the program a.sh is now running, that is the $0 value, followed by the second parameter is 3 and the first parameter is 1, and the parameter list was 13d, which I have passed as parameters here, and it is asking the user to enter the input. So I will give the input, so it shows the output. That is about the parameter variables. We will discuss about conditions. Fundamental to all programming languages is the ability to test conditions and perform different actions based on those decisions. And a shell script can test the exit code of any command that can be invoked from the command line, including the scripts that we have written for ourselves. That's why it is important to always include an exit command with a value at the end of any script that we are going to write. And now we will discuss about the test command. In practice, most of the scripts make extensive use of square bracket or test command, which is the shell's boolean check. On some systems, the square bracket and test commands are synonymous, except when I use left square bracket command, I need to use a trailing right square bracket, which is also used for readability. Having the left square bracket command may seem to be a little odd, but within the code it does make the syntax of the commands look simple, neat, and more like other programming languages. And I will introduce the test command for you using one of the simplest conditions for checking to see whether a file exists or not. The command for this that we are going to write here is test space -f space file name. So within a script you can write the example like if test, that means after if we need to provide space, if space test space -f space file name, then I need to write some statements if the condition is true, and I will close fi. That is the command used to close the if condition. You can also write the if condition by using the square bracket, which is represented on the screen. If space open square bracket space -f space file name space closed square bracket, then the statements to execute in the if condition, and closing if condition with fi command. When we are using the test condition, the condition types that we can use here are categorized into three types. One is string comparison, arithmetic comparison, and file conditionals. When we look into the string comparison, the following are the list of string comparison operators, where string 1 equals to string 2 returns true if strings are equal, string 1 not equals to string 2 returns true if the strings are not equal, -n space string returns true if the string is not null, -z space string returns true if the string is null. So that is a description of the string comparison. And the following table shows the arithmetic comparison, where expression 1 equals to expression 2 returns true if the expressions are equal, and expression 1 not equals to expression 2 returns true if the expressions are not equal. Third one, if expression 1 is greater than expression 2 returns true. Fourth one, if expression 1 is greater than or equals to, it returns true. Then expression 1 is less than expression 2, then it returns true. Then expression 1 is less than or equals to expression 2, then it returns true. And in the last one, if the expression is false, then it returns true, and vice versa. So this is the description of the arithmetic comparison. Now we'll discuss about the file conditionals. The following are the list of file conditionals that are available. -d space file represents, it returns true if the file is a directory. -e space file returns true if the file exists. -f space file returns true if the file is a regular file. -g space file returns true if set group id is set on the file, and so on. So now I'll show you the description of the file conditionals. So this is the description of the file conditionals that are available. Now I will show you a simple example of the conditions where I want to test the state of the file /bin/bash is a file or directory with the help of two sets of lines of code. The first set of line of code contains the file conditional -f. The second set of line of code contains the file conditional -d. So now I will execute the same in the terminal. It shows the file exists, and when I execute the second set of line of code, this is the program where I am passing -d as the file conditional. It shows this is not a directory, because in the previous execution we have observed that it is a file which was exist. That means bash is a file, it is not a directory. Now we'll look into the control structures. The shell has set of control structures. Now we'll discuss about if control structure, and the syntax is shown on the screen, where the bolded letters represents the commands that is to be used in writing the if condition, and a common use for if is to ask a question and then make a decision based on the answer. I will show you an example of if condition. So where I am asking the user to enter the input like yes or no. If the user enters the input, it will be stored in the variable time of day, and that will be compared with the string. Now I will execute it in the terminal. When I execute it, it shows the output like this. When I enter yes, it shows good morning, and when I enter no, it shows good afternoon. Now I will discuss about elif. The syntax of elif is shown on the screen, and the example is I have modified the if condition by writing some elif condition into it, where if condition is compared with yes string, and elif the condition is the variable is compared with the string no, and if these two conditions not satisfied, the else block will be executed. So now I will execute the same. It is asking the user to enter the input. I have given yes. If I specify no, it shows good afternoon. But what happens when I execute either if program without specifying any input, or either else program without specifying any input? So I think you have observed the screen. When I execute the if condition, if program with if condition without specifying any input, it shows that there is an unexpected operator equals to. And also in case of elif, it shows the same followed by the else block that is to be executed, and shows the statement that is available in else block along with the error unexpected operator. But why this error occurred when we don't provide any input for the program? The reason is I need to pass the variable name by enclosing in double quotes, but I didn't pass the variable name enclosed in double quotes in the example, if you observe. Now I am going to modify this program. I will show you in the terminal. Here I have modified the variable name with double quotes. Earlier it was not passed with double quotes, so it shows there is no string if I don't pass any variable name. So if I don't pass any value, there is no string. When there is no string, it looks like the following, that is shown on the screen, which is similar to if square bracket equals to yes. I don't have anything on left hand side of equals to operator, so it shows it is a error, that is we have unexpected operator here. So to avoid this, I need to enclose the variable in double quotes so that we can avoid that. And when I don't pass any value, as the variable is expanded when I represent the variable name in double quotes, so it may be treated as an empty string, so that empty string is compared with yes, and if the condition is satisfied, it will execute. If the condition is not satisfied, it will not execute. So now I will execute this program. When I press yes, it shows good morning. When I press no, it shows good afternoon. And when I press enter without giving any input, it shows not recognized without showing any error message, because it is treated that as an empty string, which is similar to the following. So that is, the empty string is compared with yes. In the same way, in elif also, $time of day is replaced with empty string and it is compared with no. So these two conditions are not satisfied, so else block will be executed. For construct. Use the for construct to loop through a range of values, which can be any set of strings. They could be simply listed in the program, or more commonly the result of a shell expansion of file names. The syntax is very simple, which was shown on the screen. Now I would like to give an example using a for loop with fixed set of strings, and the example contains the following lines of code where I am using the variable FOO, and the values of this variable are the strings bar space FUD space 43. When I execute this in the terminal, it shows the output like this, so which was shown on the screen. That is the for loop with fixed strings. We can also use for loop with another example of wildcard expansion. Imagine that if I want to print all the script files starting with the letter F in the current directory, and you know that all the shell scripts are end with .sh as an extension. So we can do this by the following lines of code where I am using the for loop by specifying the value with the command. So now I will execute the same in the terminal. Before executing that, I don't have line printer command because I am using an application in Windows operating system. So the line printer command LPR will not execute. The purpose of this LPR is to print the content of the file onto the paper. So now I would like to execute the same, but instead of using LPR command, I am using cat command. If you want, you can use more command also to display the content of the file. When I execute it, it shows the output like this, which may print the content of the file with the help of cat command, which was specified in the code. That is cat space $file, where $file is available with ls space f*.sh. So I will show you the output of this command ls space f*.sh by executing it on the terminal, so that you can identify the contents of how many number of files are shown as an output here. So these are the number of files that are available, that is FOO parameter.sh, FOO return.sh, and FOO test.sh, and far.sh and far2.sh, of which the content will be displayed as an output here. So for you to understand, I have enclosed it, that means I have written this symbol in the code. So we can look into the code for clarity. So here I have used some 3 star notations to separate the content of one file with another file. So by looking into the output, we can identify that up to here this belongs to one file, then so this belongs to one file. So likewise I have separated by using some indication like triple star. That means you can use any kind of notation here. We will discuss about while loop. Because all shell values are considered strings by default, the for loop is good for looping through a series of strings, but it is not so useful when you don't know how in advance how many times you want the loop to be executed. Means when I want to repeat the sequence of commands, but I don't know in advance how many number of times they should execute, then in that case you will normally use while loop, which has the following syntax shown on the screen. And for example, I will show you the line of code where I am going to check for the poor password checking program. I am writing the while condition like this: while $try this not equals to secret. If the condition is true, then it will enter into the loop and it will execute the lines of code that are available in while loop, and it will comes out if the condition is not satisfied. So now I will show you the output in the terminal. This is the code. Here I didn't write any statement. So now I will add one statement here. Now I will execute it. So it is asking for password. So the password is not correct. So the while condition is satisfied. So it is asking the user to enter the password correctly. So now when I enter secret, so it shows this is the while loop. Earlier in the screen I didn't write any statement after done, so we may not expect this line. That means I will remove the line in the program by commenting it, and when I execute it and when I give the password secret, it shows nothing. Similarly, we have until condition. So this is an example code regarding until condition, where we need to write the condition. Until the condition is satisfied, it will execute the statements in it. So now I will show you an example here. So I will execute it. When I give the password, it shows sorry, try again, because it is not equals to secret. So I will give the password, it shows, it comes out from the code. And the syntax of until loop is until the condition is satisfied, do the following. So now I will discuss the case construct, so which is a little more complex than that we have encountered so far, and the syntax is showing on the screen. The case construct enables us to match the contents of the variable against the patterns in a quite sophisticated way, and then allows the execution of different statements depending on which the pattern was matched. Here we have to make an important note in the pattern line. When it is terminated with double semicolon, like the break statement in case of C, and we can put multiple statements between each pattern and the next. So a double semicolon is needed to mark where one statement ends and the next pattern begins. So now we will see an example. Before that, we should be careful with the case construct, because if you are using the wildcards such as star in the pattern, the problem may arise that the file matching pattern will be taken even if a latent pattern matches more exactly. We will see an example now. This is the code. Now I execute the code, and when I enter small capital Y small es, and when I specify yes also, it shows sorry, answer not recognized, even though the pattern small letters after the first pattern is matched. It shows sorry, answer not recognized. So now I will enter yes in lowercase, it shows good morning. Now we'll see another example in case of case construct, putting patterns together. So this is the example program where I am placing all the patterns in a single line. So now I will show you the same in the terminal. This is the code, and when I execute it and when I give input, it shows the output. And also I can show another example of case statement where I can execute multiple statements. Earlier I have executed only one statement when the pattern is matched. Now I would like to write multiple statements within the pattern. So that is shown in the terminal. This is the code, and when I execute it and when I give input, it shows the output.